Hello everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about numericals problem based on that EMF and Nernst equation. So before discussing these problems based on that EMF and electrode Nernst equation, so first we discussed about what is electrode potential. So electrode potential, electrode means it is a maybe either anode or cathode which conduct electrons. It is a metal or metallic rod is called electrode. So electrode potential, strength of electrode is called electrode potential. It is denoted by symbol as E, capital E. So what is electrode potential? The natural tendency of metal or the tendency of metal to get oxidized or reduced. Oxidized means when it is undergoes oxidation, that means loss of electrons. So the natural tendency of metal to get oxidized or reduced when it is dipped in same own salt solution is called electrode potential. So the tendency of metal to get or oxidized or reduced when it is dipped in same own salt solution. For example, a zinc electrode. So zinc electrode dipped in zinc sulfate solution, same electrolyte solution, same own salt of electrolyte. So when zinc undergoes oxidation, so loss of electrons or otherwise it reduces gain of electrons. For example, copper electrode, when it is dipped in copper sulfate solution. So in this case it acts as a cathode, that means reduction reactions takes place. So what is the meaning of electrode potential? The tendency of metal to get oxidized or reduced when it is dipped in same own salt solution is called electrode potential. Electrode potential. It is denoted by capital E. So when the metal is placed in solution containing its own ions, so then the metal may undergo either oxidation or reduction. That means, for example, zinc and copper electrode. So when the zinc when we dip in same own salt solution means zinc sulfate. So in this case it undergoes oxidation, that means loss of electrons. So in that case zinc electrode acts as anode, or otherwise copper electrode dipped in copper sulfate solution. So in this case it is gain of electrons, that means this copper electrode acts as cathode. So the metal is placed in a solution containing their own ions. So then the metal may undergo either oxidation or reduction. So if the metal undergoes oxidation, then the metal ions may pass into the solution. So when the metal undergoes oxidation, for example, any metal when undergoes oxidation. So when undergoes oxidation, so in this case, oxidation means loss of electrons. So here metal undergoes oxidation, then gives loss of electrons. So if the metal undergoes oxidation, then the metal ions may pass into the solution. Metal ions, for example, zinc electrode dipped in zinc sulfate solution. So here zinc acts as anode. So when it is undergoes oxidation, this zinc metal ions may pass into the solution. In this case it develops oxidation potential. In this case it develops oxidation potential. Or otherwise if the metal undergoes reduction. If the metal undergoes reduction. So in this case the negative ions may get deposited over the metal. So reduction means gain of electrons. So metal ions gain of electrons then deposited there as metal. For example, copper electrode dipped in copper sulfate solution. Here copper electrode undergoes reduction, that means it acts as a cathode. So in this case negative ions may get deposited over the metal. So here in this case it develops reduction potential. Reduction potential. If the metal undergoes oxidation, in this case it develops oxidation potential. So the potential difference between oxidation and reduction is called EMF, cell EMF. Electromotive force. So electrode potential means the natural tendency of metal to get oxidized or reduced when it is dipped in same own salt solution is called electrode potential. So if the potential difference between two potentials, oxidation potential or reduction potential, so in this case that is called cell EMF. So now let's discuss problems based on that EMF. So calculate the EMF of the voltaic cell. Voltaic cell means it is also called as electrochemical cell, which converts chemical energy into electrical energy. Which converts chemical energy into electrical energy. So calculate the EMF of voltaic cell. So here combination is iron and copper voltaic cell given here. So here given the electrode potential of copper and iron are 0.34 and minus 0.44 volts respectively. So iron and copper electrode potentials are, so iron electrode potential is minus 0.44 and copper electrode potential is 0.34. So now calculate the EMF of this cell. So what is the meaning of EMF? The potential difference between two electrodes. Either one is acts as anode, another one is acts as cathode. So the potential difference between two electrodes is called cell EMF. So in this problem it given two different types of electrodes are iron and copper. Here in this problem it given their voltages also, electrode potential values also. So now we can calculate the EMF. So what is the formula of EMF? E cell equal E cathode minus E anode. E cell equal E cathode minus E anode. So here EMF or E cell it's equal E means capital E means electrode potential. So here electrode potential of cathode minus electrode potential of anode. So here cathode here we are taking from cathode, which one acts as cathode? Copper. So copper acts as cathode and iron acts as anode. According to electrochemical series, copper and iron combination, copper acts as cathode, iron acts as anode. So what is the formula? E cell equal E naught copper minus E naught iron. So here already we know that copper value, electrode potential of copper is 0.34 volts minus, and anode iron electrode potential value is minus 0.44 volts. So it's equal 0.34 volts minus plus 0.44 volts. So EMF of the cell is 0.78 volt. So the given voltaic cell EMF is 0.78 volts. Next, second one. Calculate the EMF of the cell if the reduction potential of the cell are minus 0.763 volts and 0.337 volts. So here also you can calculate the EMF, electromotive force. So what is the electromotive force? The potential difference between two electrodes, cathode and anode, is called cell EMF. So how can you calculate the cell EMF of given cell? So here E cell equal E cathode minus E anode. So here cathode 0.337 value and anode negative charge. So here minus 0.763 volts. These two are substituted in this formula. We'll get finally EMF of the given cell is 1.1 volts. EMF of the given cell is 1.1 volts. Generally this 0.33 related to copper and minus 0.763 related to zinc. So this is which type of galvanic cell? Zinc and copper electrochemical cell. So one more problem based on that EMF. So calculate the electrode potential of copper wire dipped in 0.1 m copper sulfate. So calculate the electrode potential of copper wire dipped in 0.1 m copper sulfate solution at 25 degrees centigrade. So here it given concentration and here it given temperature. So the standard electrode potential of copper is 0.34. So in the data it's given more concentration of electrode and temperature and electrode potential of copper given. So now calculate the electrode potential of copper. So here standard electrode potential given. So we can calculate the electrode potential of copper. So see here, E naught cell standard electrode potential of copper electrode is 0.34 volts. Formula is here. How can we calculate the electrode potential of copper? So by using Nernst equation. So what is Nernst equation? So previous classes already we discussed what is Nernst equation, what are the applications of Nernst equation. So Walter Nernst, scientist, he was proposed a mathematical relationship between concentration, temperature and pressure, or concentration of H plus ions. So he given one relationship, that equation is known as Nernst equation. It helps to determine calculation of electrode potentials. So here by using Nernst equation we can calculate the electrode potential of this electrode. So here what is the formula of Nernst equation? So E equal E naught minus 0.0591 by N log 1 by concentration of Mn plus, or otherwise E equal E naught minus 0.0591 by N log concentration of products by reactants. So here we are using this Nernst equation. E equal to E naught minus 0.0591 by N log 1 by concentration of Mn plus. So here E naught value of copper already given here. So what is that? 0.34 volts. So we can substitute here. E naught value is, E naught means standard electrode potential. Capital E means single electrode potential. So what is the meaning of electrode potential? The tendency of metal to get oxidized or reduced when it is dipped in say own salt solution. If the metal undergoes oxidation, in this case it develops oxidation potential. If the metal undergoes reduction, in this case it develops reduction potential. So the potential difference between these two electrodes are called EMF. Already we know that. So here capital E, it is a single electrode potential. E naught, standard electrode potential. Here standard electrode potential of copper is 0.34. So we can substitute it in this equation, and minus 0.0591 by N. So how many electrons involved here? So generally copper undergoes reduction. So gain of 2 electrons from copper deposited there as copper. So how many electrons involved? 2 electrons. So we can substitute here 2. So E naught means 0.34 minus 0.0591 by N means 2 electrons log 1 by concentration of this copper sulfate solution is 0.1. So we can substitute it E naught value and number of valence electrons involved in that reaction and concentration of this copper sulfate solution. So next we will get, after calculation we will get 0.34 minus 0.03. 0.34 minus 0.03. So it's equal 0.31 volts. So electrode potential of copper wire is 0.31 volts. So in this way you can calculate the electrode potential of a given electrode by using Nernst equation. So one more problem based on that electrochemical cell of Nernst equation. So here the standard reduction potentials of zinc and copper are, zinc electrode potential, standard electrode potential is minus 0.76 and copper standard electrode potential is plus 0.34 volts respectively. So what is the EMF of the cell? So in this equation, zinc and copper electrochemical cell, here it's given molarity, that means concentration of that solutions, electrolyte solutions. Here zinc sulfate molarity is 0.05 m, molarity means concentration, and copper sulfate concentration is 0.005 m. Here we are using 2 electrodes, zinc and copper. In this data it given a standard electrode potential of zinc and copper and the concentration is also given here. So now you can calculate the EMF of the cell. So here zinc standard electrode potential of zinc value is minus 0.76 volts. So negative sign indicates that oxidation potential, positive sign indicates that reduction potentials. So a standard electrode potential of zinc equal minus 0.76 volts. And standard reduction potentials of copper equal plus 0.34 volts. So how can we calculate the EMF of the cell? E cell equal E cathode minus E anode, or otherwise E cell equal E copper minus E zinc. So E cell equal E copper. Copper standard electrode potential is 0.31 volts minus, and zinc standard electrode potential is minus 0.76 volts. So then after calculation we'll get 0.34 volts plus 0.76 volts equal 1.1 volts. So EMF of the given cell is 1.1 volts. Now we can calculate the E cell value E by using Nernst equation. So E cell equal E naught cell minus 0.0591 by N log concentration of zinc by concentration of copper. So here E cell equal E naught cell value, just we calculated, what is that? 1.1 volts. So 1.1 we can substitute in this formula, minus 0.0591 by 2. That means, for example, what is the cell reaction? Zinc undergoes oxidation, then gives zinc metal ions and loss of 2 electrons. So these 2 electrons gained by copper, copper gain of 2 electrons, then deposited there as copper. Okay. So here how many electrons involved? 2 electrons. So 0.0591 by 2 log 0. What are the concentration of zinc? 0.05. So we can substitute here. And next copper concentration is 0.005 given in the data. So we can substitute concentration values also in this formula. So finally we get E cell equal 1.1 minus 0.0591 by 2 log 0.05 by 0.005. So after calculation we'll get E cell value of given cell is 1.07 volts. 1.07 volts. Next one is write the overall cell reaction for zinc and silver. So zinc molarity concentration is 0.2 and silver concentration is 0.002 m. So calculate the EMF of the cell at 25 degrees centigrade. So the standard EMF of the cell is 1.54 volts. So here it's given standard EMF of the cell and temperature and concentration of the electrolyte solutions given here. So now E naught value of given cell is 1.54. That means EMF of the cell is 1.54. So formula E cell equal E naught cell minus 2.303 RT by NF log concentration of zinc by concentration of silver. So here concentration of zinc by concentration of silver. So E cell equal E naught cell, this value given directly 1.54 in this data. So you can substitute here E naught cell value is 1.54 and so E cell equal E naught cell minus 2.303 R. R means gas constant. Its value is 8.314 kilojoule inverse. Okay, and T means temperature 25 degrees centigrade or 298 Kelvin degrees. Okay, and next N is number of valency electrons involved in that reaction. And F means 1 Faraday. 1 Faraday equal how many coulombs? 96,500 coulombs. So here 2.303 RT by NF log concentration of zinc is 0.2 and concentration of silver in the data is 0.002 m. So E cell equal E naught cell value is 1.54 volts minus, we can substitute this R, T, N, F values in this equation. So finally we get 0.0591 by 2. Here 2 electrons are involved in that. So 0.0591 by 2 log 0.2 by 0.002. So after calculation, we'll get E cell equal 1.4809 volts. 1.4809 volts. So in this way, you can calculate the EMF values of the given cell by using Nernst equation. So one more problem we'll discuss based on that Nernst equation. So calculate using Nernst equation cell potential of the following electrochemical cell at 298 Kelvin. Calculate the using Nernst equation. So already we know that what is the use of Nernst equation? It is mainly used for determination of standard electrode potentials, and also used for determination of pH, and also used for number of valence electrons involved in that reaction. So easily understood by using this Nernst equation. So here calculate the using Nernst equation cell potential of the following electrochemical cell at temperature is 298 Kelvin. So your given cell is zinc and zinc plus 2. The concentration is 0.04 m. So the concentration of zinc sulfate is 0.04 m. Here zinc electrode dipped in zinc sulfate solution. So already we discussed previous classes what is the electrochemical cell, how to represent the galvanic cell. Easily we discussed. So today's session we'll discuss about that problems based on that electrochemical cell by using Nernst equation. So here electrode and electrolytic cell both are separated by a vertical line. And here also electrode and electrolytic solution separated by a vertical line. So these two electrodes are separated by two vertical lines. These are indicates salt bridge. This is salt bridge. This is a representation of galvanic cell. Already we discussed previously clearly in that class. So now calculate the Nernst equation cell potential of the following electrochemical cell at 298 Kelvin. So zinc concentration is 0.04 m and tin concentration is 0.03 m. So standard electrode potential of zinc is minus 0.76 volts. And standard electrode potential of tin is minus 0.14 volts. So how can we calculate the electrode potential of given cell? So Nernst equation for the electrochemical process at 298 Kelvin. So first write in the chemical reaction what are given in the data. So zinc and copper concentrations you can write first. Next formula, what is Nernst equation? E equal E naught minus 0.0591 or sometimes I write 0.0592 by 2. 2 means how many electrons involved here? 2 electrons. So 0.0591 by 2 log concentration of zinc by concentration of tin. So here EMF of the cell. How can you calculate the EMF of the cell? The potential difference between two electrodes. So cell EMF equal E cathode minus E anode. So here given that according to data, zinc standard electrode potential is minus 0.76 and tin standard electrode potential is minus 0.14 volts. So we can substitute in this formula E cell equals E naught cathode minus E naught anode. So here we are taking cathode is tin and E anode is the zinc according to electrochemical series. So zinc is having more anodic nature, so it is acts as anode compared to tin. So here we can substitute the standard electrode potential of tin and zinc. So when we get 0.6062 volts. So the EMF of the given cell is 0.62 volts. So also here the concentration also given here. Zinc concentration is 0.04 m and tin concentration is 0.03 m. So upon substitution in Nernst equation we will get. So what is Nernst equation? Already we know that E equal E naught minus 0.0591 by n log 10 concentration of tin by concentration of zinc. So concentration of zinc by concentration of tin. So by using this Nernst equation we can calculate the electrode potential of given cell. So here EMF of the cell is 0.62. So we can substitute here 0.62 minus 0.0591 by number of valency electron involved in this 2 electrons. So by 2 log 10, concentration of zinc is 0.04 and concentration of tin is 0.03. So all the values substituted in this Nernst equation, finally we'll get electrode potential of given cell is 0.616 volts. So in this way you can calculate the electrode potential EMF of the given cell by using Nernst equation and EMF of the cell. So today's session we'll learn about what is electrode potential, what is the meaning of cell EMF, how can we calculate the EMF of the cell, and also we can calculate the electrode potential values by using Nernst equation. So I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.